Hey guys, my name is Hasib Badani. I am with a company called RAFAY. Our booth is in that corner over there. Are you with me? Are we here to rest our feet, watch a demo? A bit of both. If I could just get a sense, are you guys practitioners of containerized environments? You know what Kubernetes is? You have played with Kubernetes? Doing this in production, a lot of dev. How about you, ma'am? Okay, here to learn. Okay. Any specific thing around the Kubernetes environment that I should know about? You guys do or know, or? I'm just trying to wake people up, that's all. All right. So what I will show right now is the RAFAY platform in action as it relates to bring up of clusters in multiple cloud environments and on-premise environments, and then taking an application, a containerized application, deploying it across many, many environments without having to write YAML. That's the goal. Why do we do this? Because in every company out there where we are deploying containerized applications on top of Kubernetes clusters or whatever, there's a lot of effort that goes into the ongoing scripting and just the maintenance of all this. Well, many people come together to write a bunch of scripts for a bunch of clusters, and then those scripts change because the versions change, and on and on and on. So there's a pain around lifecycle management of containerized environments because we are so focused on infrastructure as code. Infrastructure as code is awesome, but there's a dark underbelly, particularly when the tools are very complex and fast changing. So we at RAFAY, we do two things. And we do them both as a service. One is we have built a really elegant abstraction layer, which is native to the tools, but for the user, for the DevOps team, it is able to take your business intent. For example, I as a DevOps engineer, I want to be able to say, I have a container, it's got this tag on it, I want to run it in these 10 places, I want to give it this configuration and this key, the ingress should be app.company.com, go. And it should just happen. We do this, all of us, many times, sometimes daily, right? But in many cases, we are doing a lot of scripting. And maybe we should simplify that effort on behalf of the DevOps team. So this platform is essentially a tool for the DevOps team to run faster. Every company I know of, even if production is perfect, somebody in dev is complaining that they're not moving fast enough because DevOps is not moving fast enough. Let's help the DevOps team, move faster by being able to leverage a tool like this so that they can go to any environment very quickly without having to learn the underlying tools. That's the intent. I will start with a high-level demo of what I call the operations console. So this platform is catering to two personas. There are two teams in any company that engage with a platform like this. One team is let's call them loosely the operations or the infrastructure team. So they are focused on the infrastructure. Where's my box? Where's my VM? Am I running in Amazon or Azure, et cetera? That's the team. And then separately, there's a DevOps team who maybe doesn't really care much about whether this is Azure or AWS or on-premise, but they care about the application. So we'll start with one, then we'll shift to the other. And by the way, if you like what you see, if this is sort of interesting, go to our website, set up an account, go for it. Just play with it. Take it for a spin, run with it in any cloud environment you want, just to see what you think. We'd love your feedback. And assuming that I am online, am I online? So I'm using Xfinity Wi-Fi. I couldn't get the Cloud Expo guys to give me an SSID. I don't know what happened there, but okay. Well, I got to be secure, so I'm going to... you know what? If you are building a portal for your own team, make sure you guys have two-factor authentication. That's important, right? 477. All right. So this company that I'm demonstrating here, this company is running clusters in these many locations. So it's a lot of clusters. You may not have these many clusters, but some do. We have a use case that we're engaged with. So this is a large retailer. This retailer has 7,000 stores. Each store has a cluster. It's a lot of clusters. So now think about it from your perspective. You are a practitioner, right? So imagine that you had to manage an environment with 7,000 clusters in different places, not in cloud. It's all over the place in retail stores. How would you build a platform to run applications across 7,000 locations? It's a non-trivial task, right? But that's the extent to where you're going to end up anyway. But this company, for now, it's running these many clusters. Now, specifically, where are these clusters running? So every row is a cluster. Now this is a really small screen. Let me make it bigger. So at least you can read. So you'll see that Mumbai cluster is in Azure. The other cluster in SoftLayer, Azure, SoftLayer, UDN, which is a data center play, MediaNova, which is a CDN in Turkey, on and on and on. Packet, which is a bare metal system. So a customer is running clusters in many different environments: public cloud, on-premise, data center, hosting provider, et cetera, et cetera, et cetera. And this platform works everywhere. Any mature company, this is the situation. There is no one cloud. There is no one data center. There is no one region. We all end up running things across multiple locations, such as life, right? We all unfortunately start with one region in Amazon and everything looks easy, and then we go to the second one and everything starts breaking, and that's where pain comes from. Distribution is a problem we don't solve for because we all start with, well, basic stuff, which is, well, hey, one region, I read a blog, this is so easy, let me just get something up, and then we go to the second region, oh my God, this is a problem. So this company is truly running in a bunch of places. Now, as an operations engineer for this company, what do I care about? What I care about is, well, this Mumbai cluster in India, it's pretty healthy. It's got enough CPU, it's got enough memory. If something, maybe a node dies, maybe too many people start putting applications on this cluster, I'm going to find out, I'm going to get an alert. So I want to know if that happens. And this cluster has 4 nodes on it. If somebody tells me, hey, I need you to add a new node into this cluster, that I should be able to do that, but that's it. So how would I add a new node into this cluster as an operations engineer? By the way, in many companies, at least large companies, it's very common for DevOps engineers to not have access to EC2 creation based on policies in the company. So they have to file a ticket to ops and say, please give me an EC2 instance. So now let's say somebody in your company set up an EC2 instance for you with Ubuntu, some Ubuntu. What do I do next to enroll this node into this cluster? You run this command. So as part of our platform, we've written a lot of open source that, of course, you are, please go ahead and take a look at it. One of the things that we built is a really elegant tool is on every node that is under management. So your nodes could be on-premise, in the cloud. They're all essentially under management of RAFAY. You run this conjurer binary, which basically authenticates and authenticates itself with our brain in the cloud, with our controller in the cloud, and it says, okay, I belong to this cluster in this new location. What do I got to do next? At that point, if this node is, let's say, running in Amazon, and you like EKS, it's going to say, you know what? I see that you're running EKS. We're going to put our lifecycle management capabilities on top of EKS. So if you got EKS, great, we'll start there. But you know what? Maybe you are that store that company with the 7,000 stores, and you have VMware ESX running inside your store. So all you have is a Linux box and nothing else. At that point, the platform will figure that out and install Kubernetes for you. So if you need Kubernetes, we'll install it. That's not value. We don't see ourselves as a managed Kubernetes company. That's not the value here. It's the lifecycle management. If you need it, we don't want to say to you, oh yeah, go figure it out first and then come back to us. So we provide that as essentially a free offering, the managed Kubernetes service. But this is the extent to which the operations person cares about. They have an environment up and running. Now let's look at what a developer or a DevOps engineer would do to run an application, maybe one container for now, simple use case, across many, many, many locations. So I'll log in as myself. All right, so as a DevOps engineer, I maybe don't care much about the operations environment. I don't care about the compute pool. What I care about is I have an app. It's called Test App. I've got a tag on it called Latest. And so some companies host their own registries, which is a very common thing. If you have your own registry, we will work with your registry, which means you have a CI pipeline that built an image and it parked a container image into a registry. If you have one, we'll engage with that registry. If you don't have one, which happens, at least in dev environments sometimes, maybe you don't want to use the DTR, which is the production DTR. We provide a registry also. So this platform is very unopinionated. We don't want to force our customers to do certain things in a certain way. This also goes back to the other UI I showed you before. If you are using managed Kubernetes from Amazon or whoever the hell you care about, right? Whatever, no problem. Work with them. Great. If you don't have one, we'll give it to you. Similarly, if you have a registry, great. If you don't have one, we'll provide you one as a free service. We don't charge for these things. We charge for essentially think of us as a managed control plane. So we charge for every node that is under management. So you can start with like a small cluster of 5, 6, 7 nodes. It's a very small price. And if actually this is a meaningful tool for your company, of course, you end up paying us more money, but at that point, you want to pay us more money. So let's take this test app, latest, and let's deploy this globally. And let's see what happens. So I'm going to build what's called a workload. So we call it a workload specifically because in the Kubernetes world, there's this thing called a CRD that some of us may be familiar with. So we have written a CRD, which we find to be a very, very clean approach to managing applications on top of Kubernetes clusters. So even if you end up not using a product, I would recommend that you look at our CRD implementation, which is an open source thing. Use it in your environments. It's going to make your life easier. But we use this concept of a workload CRD to build applications. So I'm going to build an app called Cloud Export Demo. All right. So as a DevOps engineer, at a very, very basic level, I need to think about 3 things, and I will be up and running in production. This app, called Test App, it needs to receive traffic. So what is the host name or whatever IP address that I need to have exposed so people can interact with this application? Just ingress, right? What is that? Second is the actual container. So are there policies on the container that I need to think about? Auto scaling, log aggregation, et cetera. And then placement. Where do I run this code? 1 place, 5 places, all the places available? Third question. If you do these 3 things, you're going to be production ready. And I'll do them right now. So first thing is ingress, right? So how do I receive traffic for this application? So for now, I'll create a host name, Cloud Expo Demo. So it's going to create a host name called cloudexpodemo.run.rafay.edge.net. If you were to use this product, this host name here would reflect your company, of course. This is my company. So you would have, your developer should be able to check in code, and they should be able to have their code running on a cluster, and they should get a response back in a minute and a half to say, hey, your application is accessible now on, abc.company.com, start testing. So instantly, they should have that reaction from your pipelines that you built. So I'll use this for now. And then I'll add a container. By the way, if you have more than 1 container in a workload, which is a very common thing, right? You may have you have a Redis maybe a container, starts with 3. You have a front-end container, maybe a back-end container. So your application may be a little bit more complex than my simple one, which is 1 container. So then you have to think about isolation. You have to think about namespaces. You have to think about service meshes. So when a customer has more than 1 container in a workload, that indicates intent to us. What that means to us is you probably need a service mesh. We just build one for you. So nobody in your company has to now go learn how Calico works, for example, or how Istio works. You describe to us intent, and we automatically instrument the underlying technology for you. And we provide that as a managed service. So this is why people use our product. Look, our customers completely understand what this is, right? They can do this themselves. Of course, you can do this. What we built, you could do this. You do this today. This is your job. But the thing is, everybody's busy. We have lots of stuff to do. And this basically automates a lot of the work that you do on an ongoing basis so you can focus on the more important things. Unfortunately, given how complex these tools are, many of us find ourselves being in an inverted situation where 80% of our time is spent on the repetitive stuff because it just shit breaks, right? Bad things happen, and what do we do now? We go back and fix the script that somebody wrote a year ago. And maybe that guy left the company already. Now I got to figure out how this works now. This is crazy. We should have a better way to approach this problem, which is why automation is key, and we built a very, very kind of broad, elegant automation framework to solve these problems. So I'll add this container, give it whatever name. It's sitting in a registry. I'll pick that same container. Now, I'm going to ask a bunch of questions in this wizard of the developer, and these will all be high-level questions. No YAML, no scripting, nothing. Hey, do you want to expose ports on this application? Probably. What size do you want? Each replica, do you want it to be like a quarter of a CPU, an eighth of a CPU, or some custom? Do you want to auto-scale? Maybe. All right, we'll do it for you. Just tell us the things to look for, and we'll go write the underlying HPA scripts for you. You don't have to do it. We got it across any number of clusters. Do you want to collect logs? Maybe. So you know what? Give us an S3 bucket, we'll take your logs and we'll dump them there. How did we do that? We will go install Fluentd for you and we'll now configure Fluentd for you. So, hey, otherwise you got to learn it anyway. You now have to understand Fluentd and how HPA works and da. You can, but why? Why do you want to do this? We'll help you address these things. Same thing applies to metrics. So now in order for you to collect metrics, there's a tool called Prometheus. Very good tool, but you got to learn it now. That's okay, you can. You should know it. These things you have to know. But on an ongoing basis, do you really want to have somebody write Prometheus scripts for every new application that is being written? That seems maybe not a good use of your time. So we do that as part of the product. And on and on. So everything that we ask here, do you want volumes? So everybody who's doing this on-premise runs into a volume management problem. Everybody does. So we wrote a layer where we will build you volumes on top of block storage. Again, you could do this yourself, or you could buy it. Like there's 10 companies out there who do this as products. We do this as part of the service. But you still don't, to do this yourself, you have to understand this concept called PVCs in Kubernetes. You can, you should, but maybe you don't need to. And on and on. Every one of these things, underneath, there's another tool or 2 tools or 3 tools that you now have to go learn and cobble them together into a platform. And see, here's the reality. If you are writing these platforms yourself, if you fast forward, I don't know, a couple of years, you're going to have a variation of this platform. It may not have a nice UI like ours, but you're going to have a variation of this platform. Is that really what you should be doing? I mean, you're an e-commerce company. Why are you building this? You're a pharmaceutical company. Why are you building this? But we do this. We all end up reinventing the same wheel over and over again. Why? Because this market is new. This industry is new. This kind of consolidation, this kind of standardization is happening. It's already happening. It's just happening slowly. And that's not surprising. It just takes time. Kubernetes and all these things are moving so much faster than many other technologies have moved in the past, which is why we have this gap in the industry, which is we've solved for infrastructure automation, we've solved for the managed Kubernetes layer, but when it comes to the lifecycle management of the application, we have a gap in this industry. And today we do this with people. We do it, right? And maybe we should not need to. Maybe we should have a tool that makes our life easier over time. By the way, even things like, for example, upgrades. So your code will change, right? Nothing is static. Your config will change, your code will change. What do I do? Maybe I want to do a canary upgrade. The platform will do it for you. So you can say, that one cluster, start here, and if that application works in that cluster, go do it everywhere else. If we don't do it, you got to do it. You got to find a tool for this, and you got to tie this into your own pipeline. You can, or we do it as part of the platform. Again, anything I've shown you here, everything is an option. You choose what you want to use. If you don't want to do upgrades with us, no problem. You just drop me out of that, say recreate. Then you figure out how to do upgrades. Completely up to you. In fact, we encourage people to start with a bare minimum configuration just so they get a sense for how hard this problem is. Because sometimes they don't know. And then finally, placement. Where do I want to run this code? If you have experience running Kubernetes clusters, you know that today, pretty much everything that we think through, even the quote-unquote multi-cluster stuff that exists out there, effectively happens cluster by cluster. So we create labels, and we have Kubernetes configuration that is applied cluster by cluster. Long term, maybe that's not the best approach. Maybe a better approach is, that configuration that I just created, that application that I just created, you know what, I want to run it everywhere. Go. So as a developer, I have an app, I describe some high-level configuration. You saw me do it, right? And at this point, I said, these are the whatever 10, 20 different clusters I want my application to run in. And our controller, this is a multi-tenant SaaS controller, it engaged with these clusters and said, hey, you have a job to do. Your job is this new application, this new configuration, these new keys, this new underlying whatever service mesh configuration. This is your job now. Go install this, deploy this, and when the application is up and running, come and tell me. And when you do so, I will make this pin green. And in about a minute from now, these pins will start turning green, which means this application is deployed globally. And remember from the prior screen that this is not one cloud provider. This is a combination of Azure, SoftLayer, GCP, AWS, Verizon. I mean, it's just all over the place. And I mean, multi-cloud is we talk about multi-cloud, but I mean, that's a detail, right? I mean, this is absolutely running across multiple environments, and it's done. So now imagine the life, how good the life is of a developer or DevOps engineer. If they have a tool like this, they can help anybody in the company. So one of them is up, right? And the rest will come up momentarily. And we're done. I didn't write any scripts. I didn't SSH into my Linux nodes to understand how Kubernetes. No, just It's done. 3 are done, and the rest will get done momentarily. It takes about a couple of minutes end to end, you're done. We, in our teams, all of us, we are trying to build this in our own companies. We want to deliver this to our developers in-house. This is what our developers want. They don't want to think about this stuff. They want to write code, they want to check it in, and they want their code to magically show up in some clusters. That's what the developers want, right? In all of our companies. That's what we want. And today, this is a lot of pain. And the companies who have specialized on this, like, of course, Netflix and Uber and all these companies have done a brilliant job of this, but they've done this with, in some cases, hundreds of people. Hey, you could do that too, it's fine, right? The question is, should you? The question is, are there more important things in a company to do? In the Bay Area, we can at least find smart engineers to do this, right? You go outside of the Bay Area, people can't even find engineers who know how to spell Kubernetes, right? So what happens to them? The whole world is becoming, every company is now a high-tech company, which means everybody's got some software. How are they going to run this stuff? It has to be simpler than what it is today. And that was our goal with this platform. And as I'm doing a lot of talking, this is done. In fact, in my company, let's say somebody just told me, you know what? I just heard that one of the clusters is having a problem. So what do we do today? If somebody says to us, one of the clusters, one of my application in one cluster far away is having a problem, what do? We ask somebody in operations to, hey, can you open up port 22 on a security group? Can I get a PEM key so I can log into that host? And then we exec into the replica, into the pod. That's what we do, right? All of us. There's no other way to do it. Here's a better way. From the same portal, I can go to London, the pod running in London. I should type better. This pod is running in London, but I can shell into that pod from my portal. I didn't have to open up a port on the firewall, no security group policies, no PEM keys, nothing. We built pipelines for that. Why did we do this? Because we know this is how life works for a developer and a DevOps engineer. You deploy things change, things break. You want logs back? So the left-hand side, this is essentially my tail minus F. I can see my log stream. If, of course, there was traffic here, I would see my log streaming. So now I have one system for my end-to-end lifecycle management of this application. My code gets upgraded, my config changes, my keys change, my code breaks, I fix it. One place. This is what all of us are aspiring to build in-house anyway. Whether we exist or not, you're going to do this. You don't have a choice. We don't have a choice as an industry. You have to solve this problem. This is how you make your companies more efficient. We're just saying, maybe you should have a tool to help you along the way. So that's my demo. So look, you'll see a lot of demos, lots of screen pass by, nobody remembers anything, right, 10 minutes later. If there's one thing that I would recommend you just maybe walk away with, is this is a lifecycle automation framework. It helps DevOps teams run significantly faster. Think of us as a headcount on your DevOps team. You keep hiring more people, right? Just get a tool. Get efficiency in your company. Get going tomorrow. Don't give 6-month timelines to your developers to say, oh yeah, you want to be in AWS 6 months. No, tomorrow. And you'll be up and running. And if you want to play with it, go to our website, rafay.co, sign up for an account, see what you think. We'd love your feedback. And again, our booth is in that corner all the way there. If you have any further questions, if you want to understand how some of these things work, I'll be there for most of the day. Happy to walk you through the platform. Thank you.